Line 4y equals 3x plus 1 intersects the curve xy equals 28x minus 27y at the point P, 1, 1, and at Q, where we don't know what Q is yet. The perpendicular bisector of PQ intersects the line y equals 4x at point R. Calculate the area of the triangle PQR. So perhaps a diagram to visualize what's going on would be helpful here. So we've got a line and a curve. We have no idea what this curve looks like, but what we do know is this line intersects that curve at 2 points. Let's say it intersects that curve at this point here, P, which we know has coordinates 1, 1, and Q, whose coordinates we don't know. What we're then going to find is the perpendicular bisector of that. So that is the line that's going to come through here. And we know that intersects another line at a point R. So that's going to intersect some other line, y equals 4x, at some point R. What we are then looking for is the triangle PQR, the area of that triangle that connects those 3 points. But obviously, to be able to do this, we need to know the coordinates of all 3 points, P, Q, and R. We know P, so let's find Q first. So to find Q, we're going to start by rewriting this as y equals 3/4 x plus 1/4. And given that P and Q are the intersection of this line with this curve, we're going to substitute this into this equation. So we get x times, but instead of y, I'm going to have 3/4 x plus 1/4 equals 28x, take away 27y, but y is this thing again, so 3/4 x plus 1/4. I'm going to multiply through by 4 just to get rid of all those fractions. So multiplying everything through by 4, I'm going to get x 3x plus 1 equals 28 times 4 is 112x. Take 27 3x plus 1. Now that I've multiplied through by 4 and I've got everything in integers, I'm going to expand. So I get 3x squared plus x equals 112x. Take away 27 times 3 is 81x. Take away 27. And then rearrange this, because this is a quadratic, into 3x squared. 112x take away 81x, and then bring that onto the other side, is going to give me a total of minus 30x, and then plus 27. These are all divisible by 3, so simplify this down to factorize. Going to be x minus 9, x minus 1, which gives me the values x is equal to 9 or x is equal to 1. Now we know x is equal to 1. This one here is P, because P is when x is equal to 1. So this is the one we're interested in. Substituting that back into this equation, we get Q is equal to the coordinate, x coordinate is 9, and then 3/4 of 9 plus 1/4 is 7. So now we know Q has coordinates 9, 7. That's a start. Now we know Q, we want to find R. To find R, we need to do the perpendicular bisector. Let's just work over this side for a moment. To find the perpendicular bisector, we need the gradient and the midpoint. Now, the gradient from P to Q, we already know, is 3/4, which means the gradient of the perpendicular bisector is equal to minus 4/3. We also need to know this point here, which I'm going to call, let me mark it on now, which is going to be called capital M. So capital M, the midpoint of PQ, is 1 plus 9 over 2 and 1 plus 7 over 2, the average of the x coordinates, the average of the y coordinates. That's 5, 4. So this line has a gradient of negative 4/3 and passes through the point 5, 4. So it's y equals minus 4/3 x plus c, where y is equal to 4, when x is equal to 5. Which we're going to solve this, and we calculate that to give us a value of c is equal to 32 over 3. Once we know that, we can find the equation of that green line, which is y equals minus 4/3 x plus 32 over 3. So that's the equation of this line. This line here has equation y equals minus 4/3 x plus 32 over 3. That red line was, well, why did I write this in red? Because that will make it easier to compare. It was this original equation we started with, which was y equals 3/4 x plus 1/4. And now what we know is that r is when this line here intersects with this orange line, y equals 4x. So now we need to know when this green line intersects with this orange line. Okay, and that is going to be a simultaneous equation. So that is when 4x is equal to minus 4/3 x plus 32 over 3. Multiply through by 3 to get rid of those fractions. Add the 4x. Tells us this happens when x is equal to 2. So r has x coordinate 2. We can write that on here. And the y coordinate, well, we can just substitute that into either the orange or the green function. The orange is the simplest, so 4 times 2 is 8. So r has coordinates 2, 8. Let's write that down here. So that was that bit there. Now, we found the 3 points. Now what we want to know is what was the area of this triangle. That's what we're trying to find now, the area of the triangle. So how do we find the area of the triangle? Well, we do the base times by the perpendicular height. Now, if you look at this triangle, we already have a perpendicular height. The perpendicular height is this length here because this is a perpendicular bisector. So we need the length MR for the perpendicular height. Let me write that down. And we also need the base, which is going to be PQ. PQ times by the perpendicular height. So if we work out each of those, we can then work out the area. So let's work out MR first. MR is equal to the square root of, we've got to get from, oh, they're here, M to R. There we go, I've got them written down there. So it's going to be 5 minus 2 squared plus 8 minus 4 squared, which is the square root of 3 squared plus 4 squared, which is 5. We also need to work out the length PQ. PQ, P was 1, 1, and Q is 9, 7. So it is 9 take away 1 squared plus 7 take away 1 squared. So it's the square root of 8 squared plus 6 squared, which is 10. So the area of the triangle, which is what we were actually interested in this whole time, is a half times the base, which is 10, times by the perpendicular height, which is 5. So that is going to give us a final answer of 25 square units. This is an example of a problem which involves lots of different parts of maths, all related to these graphs, and lots of steps to getting to the final solution. Hopefully you were able to work that out yourself. If you weren't, make sure you go through this video until you understand exactly what's going on in each stage. I've tried to use colours here to differentiate the different stages that we've worked through, so make sure you understand what's happening in each stage clearly, and think about how you can figure out what you need to do at each stage to work it out. I started with a diagram which helped me identify what it was that I needed to work out. I think that is a good option for many people.